Hello and welcome to the Data Dimensions webinar series, brought to you by the Master of Science in Data Analytics and Policy program and the Johns Hopkins University Office of Advanced Academic Programs. Today's event features a discussion with Jesse Kaczmarski on leveraging data science in energy policy. My name is Peter Huggins, and I'm the event producer. Please note today's event will be recorded and uploaded to the AAP YouTube channel under the Data Dimensions playlist. During the program, if you have any questions, please feel free to use the Q&A function, and we'll answer as many questions as possible during the latter portion of the event. With that, I will turn over the presentation to our moderator, Dr. Colin Pascal, Program Director and Senior Lecturer for the Master of Science in Data Analytics and Policy program.
Well, thank you very much, Peter. Thank you all for joining us today. I'm very excited to be hosting another edition of the Data Dimensions Talk Series, which is a talk series that we put together through the program that highlights cutting-edge work in data science and data analytics, especially as applied to the broad domain of politics and policy. So I'm very pleased to be joined today by my colleague, Dr. Chris Krompart, who is the Assistant Program Director for the Data Analytics and Policy program, as well as Peter mentioned, Jesse Kaczmarski, who is a data science researcher with the Alaska Center for Energy and Power. Jesse works on energy economics, econometrics. He's a trained economist. He has his Ph.D. in economics, and he works with the Alaska Center for Energy and Power on data collection, analysis, data governance. Is an expert in Python and R programming, and does a variety of work advancing energy policy in Alaska and using data science at the confluence of those fields. So very pleased to join him. Jesse and I met just by chance at a conference earlier this fall. We struck up a conversation about his work as a practicing data scientist, and I just thought, my goodness, this is so right in the wheelhouse of our students who are interested in using these cutting edge tools in politics and policy. And this is a particularly interesting case in Alaska, and Jesse's going to talk about data quality, the project of collecting data, and how to use it to drive policy insights. So I will turn it over to Jesse now. Jesse will have a presentation. He'll talk about his work, and then we will also have plenty of time for Q&A afterwards. So if you do have questions and things you want to follow up on, please go ahead to just drop those in the chat as we go. And then at the end, when Jesse's all done, we'll open it up for conversation. Chris and I may have a few questions, and we'll also make sure the audience has plenty of time to interact with us as well. So that said, thank you all again for joining, and I'll turn it over to Jesse. Thank you.
Good morning, everybody, and thank you, Colin. That was a great introduction. Oh, there we go. So in this presentation today, we're going to do a quick introduction about myself, about Alaska's energy information system that we currently have, and then we're going to talk a little bit about the Alaska Centers for Energy and Power's role. And then we're also going to go over a case study where we talk about things like transparency, community feedback, and the live patching of data. So I want to do a little bit of a background about myself. So as Colin mentioned, I'm a trained economist. Specifically, my areas of focus were econometrics and energy. And I come from a very academic background. So when I first came to Alaska, I was actually a postdoctoral fellow. And I found it extremely difficult to do energy economics research here because where I came from, I was working with highly regulated and data organized environments. So for example, I did my doctoral studies at the University of New Mexico, and mostly anywhere along the lower 48, you're dealing with highly regulated electric utilities and highly organized data collection strategies and areas to actually get that data. But currently, I'm a data science researcher within an academic unit, and we operate primarily with highly unregulated utilities in a very data scattered environment. So what is the Alaska Center for Energy and Power? Throughout the rest of this lecture, or I'm sorry, that's the faculty in me, that's the faculty part of me. Throughout the rest of this seminar, I'm going to be referring to the Alaska Center for Energy and Power as ACEP. And ACEP is an academic research unit. We house subject matter expertise in electrical engineering, power electronics, energy policy, energy economics, and information technology support specifically for rural utilities. We're housed within the University of Alaska Fairbanks, and we operate under a mix of grant funding and government appropriations. So I think a good place to start this talk is to think about the electric sector data fragmentation problem in Alaska. So if you were looking for electric data or electric sector data, you might go to somewhere like the the Energy Information Administration, which I'll refer to as EIA, as an authoritative source. And typically that's great for looking at things at the state level. You can even get monthly level data, but there is one limitation, which is that to be reporting to the EIA, you actually have to have a minimum amount of generation or customer threshold. So in the state of Alaska, we have about 13 reporting EIA utilities. However, we have over 180 non-EIA reporting utilities. And so there's a large gap in what official statistics are out there, especially if you're looking at the federal level, versus what is actually happening here in the state. And then in addition to that, we also have non-federally reporting utilities, but also non-state reporting utilities as well. And that's kind of where we have who knows what is actually happening in that case. And most of our rural utilities, about that 180 amount, they actually submit monthly information to the state, but as part of a rate equalization program. So there's only a financial incentive to do that, but there's no mandate to actually do that. And additionally, the biggest challenge we do face here is that there's no database that houses holistic electric sector information for the state. And when I say holistic, I'm thinking the combination of these federally reporting utilities and these non-federally reporting utilities. So here's just a general visual representation of this. The polygons that are shaded here represent some of the major utilities that are federally reporting. There are some more, so this is not a complete visualization, but all the black dots are typically representing these rural utilities that do not actually report to the federal government. And so now I want to talk a little bit about what kind of stakeholders exist in the electric sector data market, and then also the consequences of having not having a holistic representation of energy data. So some of the stakeholders are, in particular, one of the most important in the state are grant funders, specifically rural infrastructure grant funders. We also have legislature, both at the state and the federal level. We also have academics and researchers, journalists, non-governmental organizations, or these intermediary organizations that help communities actually apply for some of those rural infrastructure grants, and also community leaders. And some of the consequences that we have for a lack of holistic electric sector data is that there can tend to be a lack of consensus, especially on trends for energy in the state, and also a lack of confidence. So a lot of the conversations we have are revolving around this idea of confidence in the data that people are seeing. And then finally, a lack of supporting information, where if it's difficult to obtain information about a specific community in terms of their electric generation, it gets very difficult to actually apply for grants and set the groundwork for those grant applications. So what is ACEP's role with electric sector data, and why do we exist in this space? In general, we convert data production, or data producers generate electric sector data, and we do our magic and make it available for data consumers. Typically, we identify data sources, and that can be through both formal and informal information sharing networks. So, for example, a formal information sharing network would be going to the EIA or the Federal Energy Regulatory Commission and downloading some official statistics. But it can be as informal as reaching out to a utility manager and asking for clarification or getting electric sector data from them. And at ACEP, we then verify and validate the data. We do that through a mixture of both staff and faculty subject matter expertise in the area of energy economics and electrical engineering. And then we primarily research and fix data issues, which I'll be talking about in today's case study. And then the next stage would be to actually compile that data into formats that are useful for stakeholders. That might be through static or dynamic reporting, typically through visualizations in particular, and then through the development of databases, data portals, and community dashboards. And then finally, when we get all of that out of the way, we get to conduct our own primary research using those products that do inform energy discourse throughout the state. And so the solicitation, here we're going to start talking about the case study, but the solicitation of today's talk was to look at fragmented and inconsistent energy data, the leveraging of subject matter expertise to produce dynamic reporting tools focused on transparency and the joint cleaning, analyzing, and distribution of energy data. So let's go ahead and set the scene. And I don't want you to try to read this timeline. It's a little bit messy. I want you to focus on one area in particular. But essentially what we found was that regulators really needed, and policymakers really needed updated electric sector trends. And we were frequently responding to these informal requests from legislative aides and members of the community and general stakeholders for updated data. And so what you can see throughout this timeline is since 1969, it was relatively common to see these annual reports come out. However, since about 2012, since about 2012, the data year in particular, not the actual calendar year, there hasn't been an update to that. So we're looking at over a decade of unupdated electric sector trends. And so our mandate was to actually create a retrospective looking at Alaska's electricity trends from 2011 to 2021. And in this report, which we call the 2024 Alaska Electricity Trends Report, we looked at annualized statistics from 2011 to 2021. And in particular, we identified four areas that were important to stakeholders, which were capacity, net generation, consumption, and prices. And when I say capacity, I'm thinking the number and size of installed generating units. Net generation is self-explanatory. And then also the consumption and the pricing. In particular, the pricing is of particular interest to Alaskan communities where electricity prices can, without subsidization, can approach over $1 per kilowatt hour. And so we wanted to bring in both federally reporting utilities. And what's nice about federally reporting utilities is they're very high accuracy. However, they can be fairly low frequency. So we're thinking more so on the annual time step, especially for things like consumption and price data. And then we also wanted to bring in those non-federally reporting utilities, which tend to have fairly low accuracy, but high frequency. So that data comes in at the monthly time step, but it is reported data. And so it's not clean in any way. And we needed to do this in a very short turnaround. So from start to finish, we were looking at a time frame of about 4 months. And that's from the language development, the structure, the actual creation and cleaning, and the creation and cleaning of the data. It became it was very challenging. And then we also did a transition to a dynamic web-based reporting, and I'll talk a little bit more about why we did that in particular. So there are some limitations to paper-based reporting. Sometimes this can be referred to as paper first, but the PDF report that we originally designed had commentary on trends. Its emphasis was on visualizations that I misspelled. Do apologize. And the graphs needed to be easily interpretable. And that was a big component of it. However, there are a lot of challenges that arise from the PDF reporting structure, especially when the data that you're working with is maybe low confidence. And so a lot of the trends in Alaska that we wanted to emphasize were very small and difficult to see visually. And then you also have, and as I had just mentioned, the data confidence and turnaround time makes a static PDF relatively risky. And so when I say risky, what are some of the risks to static PDFs? Printed copies is a big one. So if you release version 1 of your PDF and it sits on a legislator's desk for 6 months, they may not have that updated version of the PDF if you were to go back and fix something. Version control is also extremely challenging on PDFs in terms of working through Google Docs, which I'll discuss in the next slide. But it can be very difficult to collaborate with a variety of subject matter expertise, with a variety of technical expertise as well within that. And it also is a potential friction point for accessing data. So if you include data in the PDF, it can be hard to get it out. And if you include links in a PDF, there's no guarantee that they're looking at a paper versus a digital copy of it. And then finally, it was very long. Over 50 pages was our initial rough draft of the PDF, and that was without data tables. And so if you're asking someone to print this out, you're going to be essentially printing a book and putting it on people's desks. And so how did we transition to a web-based process? We wrote a report, essentially the same report, through a a technology stack called Quarto. It's developed by Posit. And we did our data cleaning and transformation using R. our text through Markdown, and all of our numbers in text were dynamically generated using R. And then we used R in observable JavaScript for figures, and lots of custom CSS and HTML. And when we were doing the PDF report, a lot of custom LaTeX as well. So what was the workflow for this project? And what are some of the sticking points? We initially did the rough draft for the report structure through Google Docs with a whole lot of subject matter experts. So we were constantly creating figures, narratives, numbers, and asking for subject matter expert review. And through that process, we came up with what I would call a shell. So we had a general consensus on where we wanted to go and essentially what we wanted to show. But how we do that is the big step. So we actually went to the report development phase after this, where we used GitHub to build this interactive website. In particular, we use GitHub due to its issue tracking and tasking. So we could task members of the data science team to do X, Y, and Z, and they would be able to do that. And then we forked for major changes, and that would be something like a refactoring or a complete language change, for example, from observable JavaScript to R. And then we also enforced a multiple reviewer policy for pull requests. And we also published our report on GitHub through the use of GitHub Actions. And what's really nice about Corto and GitHub is they work very well together in terms of using actions to generate an actual website. And so that website is built upon the GitHub Pages framework. And what's the actual critical point on why we use GitHub for this process was the continuous deployment aspect. So as we develop issues, as people come back to us and say, this does not look right, we can actually do a transparent investigation using GitHub, using issues, and patch and republish that data over and over again. And so I did mention issue reporting there, and that's where the transparency element comes into play. So transparency is the central tenet of our team, and something we've really struggled with in Alaska here is there are lots of Excel files floating around from person's email box to another person's email box, and no one really knows what happened in between. There are clean versions underscore v2, clean versions underscore v2 underscore final, and no one really knows what's going on in between there. If you're lucky, you'll see someone put a comment in an Excel cell, which is great. But we really wanted to emphasize the transparency component, and how we do that is important. So there were only, we very quickly realized there's only certain individuals in the state who can actually identify irregularities in this data. That could be things like community members, utility managers, and a lot of just general institutional knowledge among subject matter experts. You know, we have a member on our team who has a lot of experience and could very quickly and very rapidly notice a small, very small, I'm talking a minute change in a figure and say, that doesn't look right. That doesn't look like weather could actually affect that. And so that was actually what we're going to talk about in the next slide. And what we also noticed is that data sources are rarely consistent. There are multiple different data sources for a particular element that we're talking about. So data that can be provided at different times of the year, and it can be more or less accurate depending on when it is. However, we did find that the later the data was reported, the more accurate it was. And we also found that unofficial sources of data can actually be more accurate than official ones in many cases. However, it gets very difficult to parse this out. For example, we will see regulatory commission dockets being open for cost of power adjustments. And the most official statistic or the most accurate or up-to-date statistic is typically just the PDF print of someone's email saying that they're correcting this number to that, and it gets added to the docket. So it gets very challenging to actually figure out what the accurate numbers are. And so now I want to kind of do a quick overview on some of the successful use of issue reporting in our workflow. So we had that initial release, and we also had that data that came along with it. And then so far we've applied 3 patches. One patch was actually applying some missing generation from a power plant that was never reported to a federal authority. And then the next were actually finding changes in data collection methodologies that caused artificial changes in our trends. But here we're actually just going to be talking about the first patch, which is how we identify missing power plant data. So we're talking specifically about the South Central Power Plant in Anchorage, Alaska. And this is a perfect example of a transparent subject matter expert review that just is something we're not ever able to catch as data scientists because the trends are just so, again, minute. It's very difficult to see, and that's something that institutional knowledge really only is able to identify. But here's an example. Steve Colt, he's a wonderful energy economist at ACEP, and just a general, he just knows a ton about energy infrastructure and a lot of institutional knowledge about electric sector data. And he kind of identified, along with another colleague of ours, that there was a suspiciously low visualization for a variety of years. And so he makes a GitHub issue. And if you remember back to the slide where I showed the picture of one of the home pages, there's a little report and issue button on every page. And so anyone in the public can create a GitHub issue. And he just identifies that he thinks that there's some missing data. And that's where we start our investigation. And so how do we do investigations? We actually, with this particular investigation, we revealed a variety of misreporting on federal reforms. And the way that we do that is we look at a bunch of different data sources. So we have a typical data source that we use for the start of our data, which is EIA 923, and that's monthly generator reporting data. And so we cross-check this with the Form 1 data, also some municipality reporting data, and even some regulatory costs. I'm sorry, the Regulatory Commission of Alaska reporting docket data. And we found quite a bit of difference. And so what we did was we actually identified 3 gigawatt hours of missing data. And I know that might not seem like a lot to people in the lower 48, but in Alaska, that's a very significant amount, enough to actually change the trends or the interpretation of trends in figures. And that's extremely important. And so we found that between 2013 and 2019, quite a significant amount of underreporting. And the result of that was actually a data patch. And I can kind of discuss how we do these data patches. So the big component of data confidence and transparency is just telling people what you don't know. Everyone knows that data can't be perfect. And if you're just identifying what isn't perfect, that goes a long way. Actually goes a lot farther than a lot of what the data we work with now has. And so we write these investigation reports, and you can see kind of this is just a snippet of that investigation report on this slide. But essentially, we do a lot of research, and then we write up a final report, and we discuss how we know something is wrong. What do the variety of different data sources actually say? And how do we decide what we're going to include? And then we also include some form of in-text footnote or citation that identifies a link to that patch note so that people can read the investigation for themselves. And here on the right-hand side, I don't know if you can see my mouse, but you can see we have 3 patches here. There's R scripts for patching the actual data itself. The README includes the investigation. And then the CSV files include a bunch of data that we collected manually to either prove or disprove a certain investigation. What's nice about this process is that, what's nice about this process and the use of Quarto and GitHub is that we can actually patch that raw data, but the raw data itself never changes. And that's extremely important. So as a patch gets added to the code base, the change in that code base triggers a site rebuild. And then the raw data is patched during the site rebuild, which is really nice. So every time the site rebuilds, it reruns all that R code in a containerized environment. And then that raw data is maintained, but all the numbers throughout the entire site are rebuilt. So all the visualizations, all the in-text numbers, they all get rebuilt according to the new data patch. And because of this, it does kind of put us in a limitation, which is that we try to be relatively agnostic about the language we include so that it can change depending on data getting added or taken away. So we won't say something like, well, we will try not to say something like, we see a general decrease in X, Y, and Z when a data patch might actually change that interpretation. So just to close this out, some of the main takeaways I want to impose on you all is that official data is not error-free. I think we all kind of knew this, but the extent to which it's not error-free can actually surprise you. We also noticed throughout our takeaway, this process in the last 8 months or so, was that writing tests may not be able to identify irregularities. So in particular, that first patch, that 3 gigawatt hours of missing net generation, there's no machine learning rolling window outlier detection model that's going to catch that. It's just something that institutional knowledge is going to, there's little substitute for it. And so it gets really challenging, especially when you're looking at low frequency data like annualized data. It gets extremely hard to actually test for that programmatically. And the biggest takeaway is that you need to become an expert in the data that you work with. So it can be really easy to go through a program or something like that and then come into a new field and say you're a data scientist and you just work on data and you're looking at distributions of data and all data is the same. But that's just not the case. And so becoming an expert and understanding what the numbers mean, what looks odd, what the irregularities look like, because typically irregularities can be pretty easy to spot once you know the data well. And so becoming an expert in the data you work with is of utmost importance. And just some future work that ACEP is currently working on right now is we did receive some state appropriations to actually organize a statewide energy data portal, which we're working on at the moment. Actually just came back from a meeting on that yesterday. And we're actually revitalizing the Alaska Energy Data Gateway that went defunct in the mid-2010s. That is still a very popular source for some of this historical electric sector data. And in that data portal, we're going to be rehosting data, redirecting people to other data sources, producing original data products, and just operating a general data mesh. And what's going to be really excellent about that is the actual combining of those data sources into products such as community dashboards and data that's useful for energy modelers, and et cetera. So that's the end of my talk. A little bit short, a little bit sweet. But if you want to see the Alaska Electricity Trends Report, you can scan this QR code here on your screen. And I just want to do a quick shout out to the amazing colleagues that I worked with on this reporting effort, Elizabeth Dobbins and Ian MacDougall here at ACEP. So with that, I will turn it back over to you, Colin.
Well, great. Thank you so much, Jesse. I mean, I have to say, of all the data dimension talks we've had, this might be the most gratifying for me because now I can point to a very concrete example to my students of why I force them to write those final reports in Quarto and why I want them to post their code to GitHub and why reproducibility is part of your final grade on some of these assignments. Because we're not doing that to torture you folks. We're doing it because folks like Jesse really do this in the real world, and it is a critical core skill, which might not be as sexy as running the coolest new neural net model or coming up with some kind of whiz-bang regression discontinuity or instrumental variables design. Just getting the data in front of your stakeholders is like the most important thing in a lot of settings. So personally, my heart is warmed by this talk, and I'm really appreciative, Jesse. Did you have something you wanted to respond to my little soliloquy there, Jesse, or I saw you take your mic off?
A huge takeaway, throughout this whole process is that it doesn't matter what you do behind your screen. What really matters is the end user. And so we spend all this time focusing on transparency and writing code in an open environment and building all this ground structure. But what the end user sees is just a report. But however, if someone comes back and says the data is wrong, it can be pretty embarrassing. And so being able to do this retroactively, the patching itself is very easy. If I do my investigation and I can just push that to main and it just the wheels spin and everything gets updated. So it's excellent in that way. But really we get to do one day of really fun and cool stuff. And the rest of the day or the rest of the week is going to be data documentation, investigations, report writing, because that's what's really important is giving people a perspective on the challenges associated with data. Because the more that they see that you're working through these challenges to represent it in its most you're trying to improve the confidence of the data. And so the more that you can give people insight into that perspective, the more they're going to trust the data. So yeah.
Great. Yeah. So I have a couple of other questions that I can start with, but then I obviously want anyone who's in the audience who wants to chime in as well. Chris, did you have something you wanted to add, or you took yourself off mic?
Oh yeah, I mean, I have
Yeah.
a lot of things I'd love to ask Jesse, but Colin, go right ahead.
No, Chris, I defer to you. Please go ahead.
Sure, I guess, and maybe it's good for kind of setting the stage for questions going forward. But I was struck by the role of people as well as some of the different tools in the tech stack that you were describing. And so, really like how you laid out the different stakeholders that are interested in this sort of work, and how collaborative the process is. And so, I was wondering if you could just like talk a little bit about how you cultivated that network of collaborators, and if there's anyone that, maybe in the future that you'd love to be able to work with that might take this work to the next level.
Yeah, I think that's a good point. So the role of people in data science is the most important role. We have all these unique tools that we can use at our disposal, but really at the end of the day, it's the inputs that matter. And you can output things in a billion different ways, but if your inputs are a little bit messy, it does not matter at all. A single visualization on a PDF is going to be much more important if it's accurate or not, versus whether or not you're producing it in this fancy form. And so the role of people really is what it felt like it was holding us back, but it was not. So we definitely run into some issues where we're working through something and then we have to take 10 steps back because we didn't understand this data source or we didn't understand what exactly we were looking at. And so the role of subject matter expertise, especially in data science, is of utmost importance. This is true not just in the energy domain, it's true in the medical domain, it's true in the public policy domain. I was having these conversations with other subject matter expertise yesterday, and I'm still learning things every day about how census blocks are organized or legislative districts are organized and how that ripples out into every data set that you work with. And so understanding the provenance of the data you're working with is super important, and really relying on people with institutional knowledge. It just cannot be understated. Um, Especially, like some of the people with the most institutional knowledge may have some of the least technical backgrounds, and it's okay. That's okay. It's really about how do you make it accessible to them so that you can both work collaboratively in a way that's going to just improve transparency and trust. Was there another part of your question?
I was also just curious, as sort of with that ode to collaboration and the role of people, are there collaborators that you'd love to work with in the future, and kind of how do you cultivate those relationships?
Yeah, that's a good point. So I think going forward into the future, we're going to try to work more collaboratively with state agencies that actually produce the data and actually try to address some of these issues at the source. So how do we kind of fix the issue where we're getting data of poor quality at the source as opposed to having to do all this on our own? Because right now there are data sources, and then we operate in this intermediary where we apply our subject matter expertise and our data cleaning skills to make that data more accurate and reliable. The real question is, how do we actually go back to the source and kind of inform some of their data collection issues? So going forward, it would be collaborating more with state agencies, and then maybe even opening up discussions with the federal agencies as well. If you go to the EIA's state energy profile page for Alaska, they have a link to the Alaska Energy Data Gateway, which is quite interesting. They're kind of saying, we don't have data on all these communities. So how can we kind of make that the norm, that people understand that there is 25% of the generation that you're looking at is missing because it's just not federally reported. And so just how do we work with data producers so that the general public and people using federal and official data sources are aware that this is not all of it?
Thanks a lot, Jesse.
Yeah, well, thank you so much, Jesse. I'm going to go to we've got a few questions from the audience, and if other folks have questions, please do chime in. I'm going to kind of synthesize here a little bit. One question that is asked is how could AI upgrade your process in data interpretation and cleaning? And I may sort of broaden that out a little bit and say, like, what other technologies are there that you think you might be looking to learn or sort of integrate into your process, going forward?
So technologies we're looking to integrate into our process more are going to be artificial intelligence or machine learning outlier detection. We don't have massive data sets when we're talking about the monthly and annual level, but really we're looking at ways that we can identify, maybe X does not equal Y, or it shouldn't be negative, or um, just trying to figure out these really small changes from year to year that can be okay. We don't want to just like remove something from a data set because it had an abnormal change. That might be something where we actually redirect that outlier to a subject matter expert. And so how do we bring subject matter experts in with outlier detection so that we can say, oh, that looks like a reporting error versus, oh, it looks like this rural community actually finally got the service date going for like a new solar panel installation or something like that. In terms of other uses of artificial intelligence, I think generally just computer vision is probably something we're going to be taking a lot more stock of, especially when we're thinking about things like regulatory commission documents, which are all in PDF form. They can be actual PDF prints of high quality, data tables, or they can actually just be scans of receipts. And so we've really struggled up until now, we've really struggled with using artificial intelligence or just computer vision in general for actually extracting data from these regulatory commission documents, especially because you can have many different sources saying different things. So how do we also incorporate the provenance of, here's the first reported value in a docket, and then here's the corrected value in a docket, but that came from an email, not an actual replication of the table. How do we actually disentangle that? And that's kind of our big sticking point, is that there are millions of regulatory commission documents. And at this point, we're kind of stuck with using subject matter expertise to review those dockets and actually parse out and make inference from them. Can we in some way use, artificial intelligence or computer vision to actually help us with that process? It's been getting better and better, especially with in-text citations for artificial intelligence. A good one for me has been Notebook LM, which is Google's experimental platform right now, where I can actually just give it a bunch of regulatory commission documents and ask it questions. And we've always kind of been able to do that, but it's always kind of not pointed to specific areas in PDFs. But now Notebook LM actually does. So it does cite an area. So if I ask a regulatory commission document, when did this rate increase and how much of a subsidy did what made up that rate, it'll actually point me to a line, and I can say, oh, that is just a hallucination, or that is actually pointing to something important. So just trying to figure out, I'd say, how we can use computer vision along with a very, very complex back and forth that exists in regulatory commission documents, because there is data in those commission documents that just does not exist anywhere else and is of utmost importance, especially when it comes to investigations.
Yeah, interesting. So both from a data cleaning perspective, but also like data ingestion, like those are sort of two different ways of looking at it. Yeah, interesting.
Absolutely.
Yeah. Okay, I want to go to another question we have from the audience. This is from Abigail. She asks, well, first she thanks you for the informational talk, which I certainly second. But then she comments that you refer to the importance of institutional knowledge in your data science tasks. And she asks, what types of organizations or staff in Alaska do you regularly collaborate with for your energy research? And that does, point me to again, kind of a broader question of kind of like, just mechanically, how big is your team? Like how often are you working on this project? What are some of the nuts and bolts and sort of like, how you've gone about developing this?
Sure thing. Yeah. So there's quite a lot to that question. I'd say that the core team of data science and data analysis is about 3 people now. So it's myself, Liz, Ian. We also have some additional data scientists that are more so in modeling components and maybe not directly related to this particular report. And then we work with a variety of academics, industry stakeholders, industry professionals, so people who have had long tenures in state agencies related to energy, also utility managers, people who work in the field and actually work with utilities, and also work with communities in terms of developing grant applications and that sort of thing. And then we also are just paying a lot of attention to journalists and too. So a lot of journalists can have information that we just don't have, you know. So those are our main areas of expertise. We also have people, you know, who work closely with the regulatory commission and just general state agencies and things like that. So they all exist in our orbit in either a formal capacity, either that they work at ACEP, or just we have these energy data working groups where we invite stakeholders of energy data too, and we all share kind of our issues and our problems and just generally trade information. We do those relatively frequently. And then have these appropriations from the state. We're also working to collaborate more closely with the Department of Natural Resources and the Alaska Energy Authority. And that's going to really help us bring more of that institutional knowledge into focus as well.
Great. Another question here from John. Are there other blind spots in terms of data in Alaska besides energy where your expertise could be beneficial? I guess the short answer is yes. Yeah.
Yes. So this is really interesting because if you notice, the title of the report is the Alaska Electricity Trends Report, not Energy Trends Report. And that's a pretty big distinction. So electricity only makes up a small portion of energy, especially in Alaska, where we have, you know, a winter peaking system where we have lots of energy needs for heating, space heating in particular. So our biggest blind spot right now, I would say, is access or information or even just any general sort of data collection on space heating. So, and a lot of the space heating in Alaska comes from the burning of fossil fuels, either through natural gas, which is relatively easy to actually get data on because that data is going to be presented to the federal government through different data sources. But also, most of our communities use diesel heating fuel oil, and that is pretty much impossible to get information on unless you're working directly with a distributor or a community in terms of actually trying to gather that data. And normally that's not super challenging. You know, you can work out relationships, but when you have over 200 communities, it gets, you know, how do you eat an elephant, right? One bite at a time. And so there's just no official or mandated data collection or reporting on space heating or the other component of energy. And that's a very big challenge when we're trying to think about things like how expensive is it to live in Alaska? Like how much do people spend on energy? When we have some estimates that non-electric energy can be upwards of 75% of someone's annual costs. And so we're missing a really big part of the pie. And so just data in general on that is just, it's our white whale right now.
Great. Well, I'm just going to see, let's see, any other Q&A here. Yeah, so I guess I'm going to ask one more question and then, and we'll let people pop anything else in the Q&A if they want to. But I guess my last question would be, when you started doing this project, Jesse, I mean, you have your PhD in economics, you were not a data scientist per se by training. So when you started doing this, or maybe just working in your position more generally, what kind of models did you look at when you were designing this kind of project? How did you get your inspiration for doing this? Like, where did the sort of the germ or the seed of the idea come from, and what steps did you kind of take to pursue that after you started to visualize that with your team?
Yeah, so we actually had there was a lot of groundwork done before this on terms of we wanted the ACEP to actually produce some sort of a trends report, so that was there. But then it really came down to we need to wrap this up, and so that kind of got put on the data science team. And so we essentially figured out a way to create something that was going to be representative of general electricity trends reports throughout the world. I mean, there are plenty of electricity trends reports at different scales, and they all cover four main areas, which is capacity. That'd be things like installed capacity by fuel type or technology. So think solar, internal combustion engines, etc., hydropower, whatever it may be. And then you've got net generation, consumption, and prices. And with those 4 areas that you can really give a holistic look into the electricity sector, especially trends in the electricity sector. And so that's kind of the process we moved through. Is we looked at a variety of different global reports. We found what the what was common between them, which were those 4 components. And then we had to make a pretty difficult decision, I'd say, in terms of how much can we actually do within the time frame that we have. And so that's where we kind of led ourselves to where we are now, which is more a relatively dry and just general reporting of the electricity trends. And then from here, though, we have established a data set that people didn't have before. And so from here, we can actually use this as a jumping off point where now we have data, reliable data, or what we're taking to calling reasonably accurate data. We can actually take that and actually start writing more narrative-driven reports on general trends in the state. So yeah, that's definitely where we came from.
Well, great. Well, thank you so much, Jesse. Once again, I think this has just been a great example of, applied data science and sort of the day-to-day work of data curation and data engineering, data management, which, as you said, I think you may have mentioned it during the talk before when we were chatting. I mean, it's 90 to 95% of the actual mechanics of a lot of the work that I think our students are interested in. So I'm very appreciative of you sharing your experience. For those of you that do want to look at an example of Quarto reporting in action, I do really encourage you to look at the electricity trends report, which is linked in that QR code. It's very interesting and should look very familiar to a lot of our students who have started to work with these tools. So thank you once again, Jesse, for joining us. This talk will be on YouTube, so if anyone wants to go back and review anything that they missed, they're welcome to do that. Other than that, thank you, everybody, for coming to another edition of Data Dimensions.
Thank you for having me, Colin. It was great.
Thank you.